Here are the answers to the exam practice. This is a variety of questions involving slope and length. Starting with question number 1, it says that the slope of JK is 3/4. They're telling us that JK and PQ are supposed to be perpendicular, and they want to know the slope of PQ. Well, if we're starting off with the slope, that's 3/4. And we want perpendicular, we want the slope to be completely opposite from the slope that we're given. So the opposite of being positive is negative. The opposite of the 4 being on the bottom is the 4 on the top. And the opposite of the 3 on the top is the 3 on the bottom. For question number 2, we want to know the slope of a line that's perpendicular to this one. Well, the very first thing is to get y alone. When you get y alone in the equation, then you'll be able to read the slope and y-intercept right off the equation. So very quickly in that question, we can add 2x to both sides. That gets the y alone, and now we can read the slope. The slope of this equation is 2. If we want perpendicular to 2, we want the complete opposite of 2 over 1, which would be negative 1 over 2. And once again, those are called negative reciprocal slopes. For question number 3, what is the equation of a straight line whose slope is 3 and passes through that particular point? So we're going to want to come up with a y equals mx plus b. We know what the slope is, but we don't know what the y-intercept is. So the ingredient that's missing is the y-intercept, or the b. They're telling me that the x is negative 2 and the y is 0. And they're telling me the slope is 3. So I put those 3 numbers into this little equation and then solve. I get negative 6 plus b on the right. On the left it's a 0. Add 6 to both sides, and b happens to be 6. So the y-intercept is 6, and the slope is 3. It must be choice 2. For question 4, there's just some quick practice using the slope formula. So subtract the y's and subtract the x's to figure out the slope. So the 2 y's in the question are 3 and 13. And the 2 x's in the question are 1 and 5. 3 minus 13 is negative 10. 1 minus 5 is negative 4. And we get negative 10 over negative 4, which is the same thing as positive 10 over positive 4, which if we reduce it is the same as 5 over 2. Choice 3. For question 5, they want to know the distance in radical form from this point, negative 2, 3, to the origin, which is 0, 0. So one way to do that is to figure out the slope first. I know they're looking for the distance, but the slope will help me figure out the distance. So the slope would be y minus y over x minus x. So 3 minus 0 are the y's. And the x's are negative 2 and 0. So my slope is 3 over, well, negative 2 minus 0 is negative 2. So the slope is negative 3 over 2. That means that the length, if you remember our shortcut with the Pythagorean theorem, our length would be 3 squared plus 2 squared square rooted. So 9 plus 4 is 13. So radical 13 would be the answer. Of course, graphing it on a sheet of graph paper could help you actually feel more confident with your answer. For question number 6, a side of one parallelogram is represented by that equation. Which equation could represent the other side? Well, no picture. I suppose I'm going to have to draw at least a rough sketch of it. It says that there's a parallelogram A, B, C, D, And what do I know about parallelograms? Is parallelograms have opposite sides parallel. They're giving me information about side AB. I know that side AB must be parallel to side CD, and if they're parallel, they must have the same slope. So I need to figure out the slope of this equation here. So we get y equals 3/2 x plus 7 when we get the y alone. So the slope of side AB is up 3/2. So which of these other equations also has a slope that's 3/2? It is choice 1. And the way I can tell that is by getting y alone. So in that equation, if I get y alone, I would be subtracting 14 from both sides. And then dividing by 2. And that would give me a slope that's matching the slope of AB. That's the only one that has a slope that's 3/2. Okay, second page, question number 7. Which equation represents a line that's perpendicular to the graph of this equation? Once again, I gotta get the y alone. It happens a lot on these questions. So in one step, I can get y alone. I'd have to divide everything by -2. So divide all of these by -2 gets my y by myself. 4 divided by -2 is -2x. And then 10 divided by -2 is -5. So the slope of this equation is -2, which is also saying the same thing as saying it's -2/1. If I want something that's perpendicular to it, I want it to be completely opposite -2/1. The opposite of black is white, I guess, and then the opposite of negative is positive, and the opposite of the 1 being on the bottom is the 1 being on top, and the opposite of 2 being on top would be 2 being on the bottom. So I need a slope that's 1/2, and right away, choice 1 fits that description. Question 8. In question 8, the vertices of a quadrilateral are given there. Using coordinate geometry, prove that DF and GE bisect each other, and also prove that it's a rhombus. Well, first thing up is proving that DE and GE bisect each other. Well, they intersect each other at this point we'll call M. To prove that they bisect each other, we'd have to prove that GM is the same as ME, and that D to M is the same as M to F. So I need to find 4 lengths there. So let me make a little chart here to organize my thoughts. I need to find GM, ME, DM, and MF. To figure out their lengths, I'll figure out their slopes first, and then I'll figure out their lengths second. I don't need their slopes, but their slopes will help me figure out their lengths. So from G to M, it's down 1 over 1. So the length would be the square root of 1 squared plus 1 squared, which would be the square root of 2. So ME must be exactly the same, and it is, of course, because the slope of ME is -1 over 1. So it's exactly the same work as above. I'm trying to show you how fast this can actually be. Turning slopes into lengths is actually can be very, very quick. So first of all, for D, now we have to go back to DM and find the slope of DM. It's up 1, 2, 3. So it's going up 1, 2, 3 over 1, 2, 3. So the slope is up 3 over 3. So the length would be the square root of 3 squared plus 3 squared. 3 squared is 9. 9 plus 9 is 18. So radical 18. That's how far it is from D to M. And from M to F, it must be the same. And it's very quick to do that because the slope of MF is also up 3 over 3. It's the exact same work as the line above, radical 18. So we know that the diagonals bisect because the segments are split, or the diagonals are split evenly, or into two equal pieces. That's a really nice complete answer there. All right, maybe the last question is probably easy. For part B is proving that it's a rhombus. To prove that it's a rhombus, you need to prove that all four sides are the same length. So it's the same amount of work with maybe a little less thinking. We need to find out the lengths of all four sides. If all four sides have the same length, then all four sides are equal to each other, which means it's got to be a rhombus. So we're going to figure out the slopes and the lengths. And again, I'm trying to prove to you that this is actually very, very quick. So let's actually take a look at the slope from D to G. It's up 1, 2, 3, 4 over 2. So the slope is up 4 over 2. For G to F, it's also up 2, but over 4. For EF, it's up 1, 2, 3, 4 over 2. The same exact slope as DG. And DE also has a slope that's up 2 over 4. Because all of those numbers are exactly the same, when I calculate the length, it's going to be exactly the same calculation for all four pieces. So the square root of 4 squared plus 2 squared would be 16 plus 4, which is radical 20. So speeding along, every single side is worth radical 20. So in a final sentence, my conclusion would be it's a rhombus. Whoop, my M got carried away there. It's a rhombus because all four sides have the same length. Okay, next page, last page. Question 9. Okay, find the coordinates of point M, which is the midpoint of QR. And it says to prove that PM is perpendicular to QR, and then prove that the triangle is isosceles. All right. So find the coordinates of point M, which is the midpoint of QR. So I need to find what's halfway between Q and R. Well, I can count up the slope. The slope is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 over 1, 2, 3, 4, 5, 6. So if the slope is down 18 over 6, to get to the midpoint, I'll go down 9 over 3. So down 9 over 3 puts me right here at this point for my midpoint. And it says to call that point M for the midpoint, I believe. Yep. It says to find the coordinates of it. So the coordinates are the point 2, 4. So it's asking for the coordinates, so I'm putting the coordinates down. Prove that PM is perpendicular to QR. Well, to prove that, I need to be looking at their slopes. If their slopes are negative reciprocals, then I know that they are perpendicular to each other. So what are the slopes of QR and MP? Well, QR, remember, was down 18 over 6. And MP, I'll have to count that one out. MP is up 1, 2 over 1, 2, 3, 4, 5, 6. So up 2 over 6. Now those don't look like negative reciprocals now, but if I reduce them, I should see it. So 1/3 is the slope there, and this slope is negative 3 over 1. And because these are negative reciprocals, they're completely opposite, you can say that QR is perpendicular to MP, and the reason is because the slopes are negative reciprocals. And the rest is for you to do. This is a lot of the work done except for the last question, question C. All right, so hopefully this was very helpful to you, and we'll catch you next time.